In this post, we want to think about the value of a measurement, either a mean or a proportion, and we really want to think about one that we don't believe is true. That is why we would use a hypothesis test, because there's a stated value and we're challenging it or questioning that it's actually true. So I'll give a few examples. One with phones, I read somewhere that people check their phones about 17 times a day. I don't think that's true. I think in our modern culture, we actually check our phones more than 17 times a day. Maybe you're a runner and you used to believe that your mean run time for a mile is around 10 minutes. But lately you've been feeling in better shape. You feel that you're going faster, so you may challenge that stated value that your mean for your mile time is 10 minutes, because now you think you're actually faster. The mean's actually less than 10 minutes. And here's just a generic pie chart that I can use to illustrate some examples with percentages. Maybe you heard that 45% of people vote in an election, and you just don't think that number is true. So you could challenge that that's a real accurate value. Or maybe that 45% of heart attacks are women and 55% are men. Maybe you don't believe that's accurate. That's a percentage that you could challenge whether it's true or not. And so I'll give an example now. Going back to the situation I mentioned in my previous video, my commute times to work, the mean of all my commute times is 14 minutes and 15 seconds is my best estimate for that. So for me personally, this is not something I would challenge personally in my life because I actually believe this value is still true. But let's say in the future, I believe it feels like I'm starting to get to work quicker. Maybe traffic seems to be lighter, or I get a faster car, or I found a new route. But for whatever reason, I start to feel that I'm getting to work quicker. Well, then my null hypothesis would be what I believe the mean used to be, and my alternative would then be that the mean's actually less than that value because I'm starting to get to work quicker in my mind. So I'd run a hypothesis test to check if this is true or not. And so you don't actually need to gather a sample for this discussion board, but how that would look would be to take a sample of trips, calculate the mean time from that sample, and then if that sample comes back that the mean's a lot less than the null, I would reject the null in favor of the alternative. If the sample comes back and I get a sample mean close to the null, then I'm just going to accept that the null is probably true. There's no reason to reject it. So one thing I would like to hear you talk about is if you were to run a hypothesis test, what would the errors be that could possibly come up? And so to talk about that, it's important to note that we always follow the data from the sample and do what it tells us to, and so we never know if we're making an error or not. So for the example I said, let's say the mean time from my sample trips comes back well below 14 minutes, 15 seconds. So I reject the null in favor of the alternative. I assume I'm making the right decision, and I probably am. Most of the time, you can trust your sample. We always do trust it, and most of the time, it is correct. It's the right decision. But it would be a type 1 error if we're rejecting the null, but it's really true. So what that would mean is that our sample was unusual or rare. Maybe I'm hitting all green lights and getting lucky, or for some reason, traffic is really light during that sample. Something happened during that sample that was unusual or rare and gave me a mean well below the null, so I rejected it. But the null is actually true. That's a type 1 error. And so what are the consequences of that would be I'm going to show up late to work because I am trusting this new result, this alternative here. But in fact, the null is true, so I'm not going to be giving myself enough time to get to work. And that would be the consequences of a type 1 error. Now a type 2 error would be to accept the null, but in fact the alternative is true. Now again, a type 2 error, I'm not going to know I made an error. I'm just following my sample. My sample would have come back with a mean close to 14 minutes, 15 seconds. So I accept the null. There's no reason to ever doubt my sample. I trust the data. But it was an unusual, it was a rare sample. And in reality, the alternative is true, that the mean is actually less than 14 minutes and 15 seconds. The consequences of that, not as bad. It would just mean I get to work a little bit early because I'm trusting the null when in fact the alternative is true. So think that through. What would be more harmful in your situation, a type 1 or a type 2 error? It's different from situation to situation. And share that in the discussion board.